Thank you all for coming to my talk today. So the way that this works, I think if you have any questions, feel free to raise your hand and I can answer them throughout the presentation. I am a final year PhD student at McGill. I'm supervised by Eric Hehman. And today I'm really excited to talk to you about our latest research. Do real world contexts matter for social perceptions of faces? So all of us have at some point in our lives met someone new. And when we meet this person, usually within milliseconds of seeing them, we're able to infer a whole rich variety of traits about their personality, their inner states, like how trustworthy they are, what kind of actions they're capable of, whether they're healthy or attractive, assertive, etc. So decades of work have found that these first impressions are rich, rapid, and spontaneous, and they can arise spontaneously and are pretty stable even when we're given new information about this individual. So critically, regardless of the accuracy of these impressions, they've been shown to have real-world outcomes, predicting who gets elected into office, who's found guilty in a trial, and how severe the sentencing is. And these outcomes are often systematically biased. Therefore, it's important to get a clear sense of how these impressions are formed and for whom do these impressions differ. So typically the way that these impressions are studied is we have a bunch of participants who are evaluating a bunch of targets. And as you can imagine, people might differ in the way that they form impressions of these targets. So Eugene might evaluate Eric as highly competent, Neil might evaluate Eric as less competent, and it all depends on a host of factors that are happening on the perceiver side and on the target side. So past work has decomposed the variance in all these different facial impressions into variance coming from the perceiver side versus the target side. And what this means in plain language is how much variance in all these different facial trait impressions is coming from differences across perceivers versus differences across targets. For example, at the top of this figure, you can see that when people are trying to evaluate how creative, intelligent, or competent a target is, people tend to disagree on what criteria to use or what these trait ratings are for various targets. Whereas if you look at the bottom of this figure, when people are trying to judge how happy race-typical or gender-typical targets are, there's a lot of consensus across perceivers. They're not disagreeing much, and a lot of the variation seems to come from variation across targets. So obviously, there's a lot of other traits where there's a healthy amount of perceiver and target variance. And one question I had after reading this work is why? Why do we have so much variability at the perceiver level? This indicates that different perceivers are disagreeing on what targets are like on all these different traits. Is it the case that perceivers are just unique in some way and they're all evaluating targets based on their own idiosyncrasies? Or could some of this perceiver variance be systematic across perceivers? So to investigate this question, we partitioned the variance in perceivers and targets across a whole bunch of different traits, looking at whether participants and targets' race and gender might be a factor. And what we found is that, first of all, perceptions are highly subjective overall, and impressions of women tend to have greater consensus than impressions of men. And one reason that we think this might happen is that participants are relying more on their consensual stereotypes of women when they're evaluating them, which leads to greater consensus. But we weren't able to directly test this hypothesis. So in other work, we also looked at perceivers, whether perceivers' unique racial and gender stereotypes constrain their facial impressions. And in this research, we found that individuals' own unique stereotype knowledge predicted the way that they would form impressions on a whole bunch of different traits for targets of different race and gender. So this is past work. One critical thing about all this research is that usually participants are evaluating targets in a very specific context. So this is what the context looks like. Participants are seated in front of a computer, typically in a social psychology experiment, and making ratings on a computer screen. While there is some work out there by Todorov and colleagues that shows that facial impressions have some adequate test-retest reliability, they don't often take context into account, and these impressions are always made in the same context across studies. So given that almost all existing research in social psychology comes from participants embedded in this context, this may impose an upper bound on the amount of within perceiver variability that could be captured and that might exist when participants are in different contexts. And there are limits to what we can learn about person perception from research conducted in this specific context. So maybe it's the case that context actually matters. People form impressions within their broader culture, situation, and social environment. And to the extent that these contextual factors are psychologically meaningful, they might shape the impression formation process. So that brings me to my research question. We wanted to know, to what extent do different contexts matter in social perception relative to the target's appearance or whatever is going on in the perceiver's head? And to answer this question, we conducted a longitudinal experience sampling study using the Experience Sampler app, and we tracked 218 participants over 15 days. These participants were recruited from MTurk, where they installed a smartphone application and responded over the course of the study. So participants were given two surveys every day up to 15 days, and every time they made a response, they evaluated a single stimulus on 6 traits. So these were within subject ratings: trustworthiness, friendliness, attractive, intelligent, dominant, physically strong. And we selected these traits because they're commonly studied in literature and reflect some of the dimensions that commonly come up in person perception research. So participants self-reported their mood, physiology, environment, and their situation features every time they responded to the app. These include, for example, items like, please describe your current environment. Are you inside or outside? How does the temperature feel? How sunny is it? To measure participants' situations, we use the ultra brief version of the situational 8-diamond scale, which measures people's awareness of their psychological situation. And these include items tapping like, are you in a situation where work has to be done? Are you in a situation where deep thinking is required? To assess participants' mood and physiological state, we used items that loaded strongly on the UIST mood adjective checklist. And these include items like happy, calm, energetic, fearful, anxious, angry, and sad. And we also included 2 measures of physiological state: how hungry are you and how tired are you? So even though it's the case that this is definitely not a comprehensive list of the ways that context can vary in daily life, we tapped items that we thought would broadly capture like how context would change across the course of 2 weeks. And we also wanted to make sure that we captured context broadly, even if we weren't maybe tapping comprehensively the specific features of each context. And this data was collected before the pandemic. So onto the analyses. Going back to our question, we wanted to know, to what extent do different contexts matter in social perception? So the way that we represented our data is we had split our analyses into an exploratory and confirmatory data set. And our contextual predictors are the 22 contextual variables that I mentioned previously. These participants make observations on these at every single time point. And our dependent variable are ratings of a trait, where we built 6 separate models for 6 traits. These ratings were cross-classified, and in the next slide, I'll explain what that means. So every time participants evaluate a target, they're making a rating from a 1 to 7 Likert type scale. And in total, we have a bunch of ratings made by a bunch of perceivers evaluating a bunch of targets. So for example, our first perceiver might evaluate these targets on a 1, 2, and 3 on attractiveness. And this perceiver has an average rating of attractiveness across all targets. Our next perceiver makes a different set of ratings, and this perceiver has a different average rating of attractiveness compared to the other perceiver. So The way that we capture perceiver variance is by looking at the differences across these perceivers' average ratings of attractiveness. And you can imagine that there's countless ways why perceivers might differ. They might have different moods, they might have different personalities, different lay theories of personality, they might belong to different social groups. On the other side, you can also see that each target is being evaluated by different perceivers. And so each target also has an average rating of attractiveness that differs from other targets. So this is how we're able to estimate variability at the target level. And you can imagine that targets might vary on things like their social identity or their facial appearance or their affect. What we really want to do is examine how much of the variance in these ratings of attractiveness can be partitioned into variance at the perceiver level versus the target level versus the contextual level. So you can imagine that a perceiver might be evaluating a target in, let's say, context A, which might descriptively look like having to do work while it's sunny outside. Another perceiver might be in the same context when they're evaluating various targets. What we want to know is whether this contextual cluster uniquely drives some of the variability in attractiveness. But unlike the perceiver cluster and the target cluster, where it's really easy to identify who the perceivers are and who the targets are, what's not so clear is how to identify whether a context belongs to context A or context B. And the next part of my talk, I'll be explaining how we did this. So the question is, what are these context clusters? Given 22 contextual variables, it would be impractical to model all of these predictors and their higher order interactions. It's just way too many parameters. What we need is to construct a single context variable where we can assign each observation. So for example, you can imagine that context A might be psychologically similar across participants. This might be the case where you're indoors, feeling hungry, and you have a lot of work to be done. What we want to do is find these distinct contexts. And to do so, we use latent profile analysis to estimate an underlying categorical variable of context from our 22 continuous indicators. And this approach has been used in the past to look at, for example, how students might have different academic profiles of motivation. It's also been used to look at profiles of personality. And here we're extending it to the different contexts that might be experienced by participants as they go about their daily life. Okay. So to do LPA, we use the tidy LPA package in R. We tested between 2 to 51 classes of contexts. So what this means for those who aren't familiar is we tested whether there are two unique contexts in our data, up to 51 unique contexts, and 51 was a computational ceiling. We assessed and compared these models by using the Bayesian information criterion and the bootstrap likelihood ratio test. And we partitioned our data into an exploratory and confirmatory set to ensure that the models weren't overfit. So in the exploratory data set, we found that the best performing model was also the most parsimonious, at least in the, sorry, not the most parsimonious, but the 43 class model was the best performing model. In the confirmatory data set, the 43 class model was in the top 3 best performing models. And since it was the most parsimonious one, we decided to use the 43 class solution. But we also did our analyses with the 48 and 45 class solutions and didn't find any changes. So on this slide, I'm going to give you some descriptives of our context cluster. On average, participants experienced 8.56 unique contexts over the course of the study. This was in the exploratory data set. And in the confirmatory data set, they experienced on average 8.96 unique contexts. So, okay, now that we have this context cluster, we can proceed on to our main analysis, which is to look at to what extent do real-world contexts influence impression formation. We partitioned the variance in 6 different ratings across 6 models into variance between perceivers, between targets, between contexts, and we also looked at the perceiver-target interaction, the perceiver-context interaction, and the target-context interaction. And this is some example R code of what this model would look like. On this slide, I have example data showing, just to give you a hint of what the data should look like. But instead of just going into each one of these different components, I'm just going to go right into the data so we can talk about it there. Okay, so in the exploratory data set, I will start with the left-hand side here. So on the x-axis, we have the proportion of variance that's attributed to each of these components. On the y-axis, we have these decompositions for every one of our traits. And as you can see, replicating past work, participants, the variance across perceivers was on average 10 to 15%. The variance across targets, so that's represented by this dark blue bar, was 10 to 15%. The largest source of variance represented by this blue bar here in the middle is the perceiver by target interaction. And this replicates some previous work showing that most of the variance in these impressions comes from different perceivers uniquely evaluating different targets. So one thing to draw your attention to is that our context ICC, the variance uniquely contributed by the context cluster, is actually pretty much 0. So what this means is that context on its own doesn't drive variability impressions in the same way for all perceivers evaluating all targets. For example, if being sunny or not was a context, then we would expect ratings to be really different when it's sunny versus less sunny, and that would give us a higher context ICC. Since our context ICCs are basically 0, it means that context, like being sunny, isn't pushing ratings in any direction. What we do find, however, is that the perceiver by context ICC is around 12 to 18%. So that's represented by this salmon bar here, this salmon colored bar. And what this indicates is that there's some interplay between participants and the context that they're experiencing. And this interplay drives some variability in impressions. So to give a more concrete example, let's say that being sunny or not was a context. Some participants might be influenced by the sunny weather, and they might evaluate targets as friendlier whenever it's sunny. But for another participant, they might not be influenced by sunny weather at all. This interaction between participants and the context is what's being captured here in this perceiver context ICC. We also see a smaller but non-zero target by context ICC, and this just means that different targets, when participants are evaluating different targets in different contexts, that also drives some variance in their impressions. So these estimates were replicated in our confirmatory data set. Okay, so to summarize, in this study, we looked at to what extent contextual factors in the real world influence our first impressions, and to do this, we estimated the variance in all these different trait impressions and partitioned them at the perceiver, context, target level, and looked at their interactions as well. What I'm also going to talk about is, in a second analysis, we looked at whether there are specific contexts that might be important for driving facial impressions. So you can already imagine that we wouldn't find any effects of context that are happening within participants, because otherwise we would have seen something in the previous slide. We would expect the context ICC to be non-zero, but it might be the case that certain contextual variables are important in a systematic way across participants. So in this analysis, we used a predictive modeling approach. Our level 1 predictors were the 22 contextual variables centered within participants. And our level 2 predictors were the participant means for each of these variables for every contextual variable. So one contextual variable might be asking about participants' mood. The dependent variable is a rating on a trait, and these ratings were cross-classified across participants and targets. Since we're making a lot of estimates, our strategy was to look at which estimates were significant in the exploratory data set and only talk about them if they were also significant in the confirmatory data set. So first, for ratings of trustworthy in the exploratory data set, there's a lot on the screen, but you only have to pay attention to the ones that I've bolded because everything else was non-significant. So here we're looking at a column called between perceiver effects. And we found a significant effect of energetic mood and angry mood on participants' rating of trustworthiness. And what this means is that on average, participants who felt more energetic evaluated targets as more trustworthy. Participants who felt more angrier on average evaluated targets as less trustworthy. But the only effect that replicated in the confirmatory data set was the effect of energetic mood. And so this is the only one we pay attention to. So in the confirmatory data set, again, participants who are more energetic on average evaluated targets as more trustworthy. For ratings of friendliness, which are highly correlated with ratings of trustworthiness, we found the same effect. Participants who are more energetic on average found targets to be friendlier, and this replicated in the confirmatory data set. For ratings of attractiveness, none of our contextual variables, whether within perceivers or between perceivers, predicted ratings at all. And this was also the case in the confirmatory data set. And the same pattern emerged for ratings of intelligence. Even though certain effects seem to be significant in one data set, they disappeared in the confirmatory data set. So we just don't talk about them. For evaluations of dominance, we found that participants who are angrier on average evaluated targets as less dominant. We also found that participants who felt hungrier on average evaluated targets as more dominant. And these effects replicated in the confirmatory data set, but only these two effects. They also replicated for evaluations of physical strength, which are highly correlated with dominance. Participants who are angrier on average evaluated targets as weaker, and participants who were hungrier on average evaluated targets as stronger. Okay, so what does this all mean? Only between perceiver effects mattered for these specific contextual factors. And this means that most contexts don't matter in a systematic way across participants and across targets. What mattered was participants' energetic mood on average. These predicted evaluations of trustworthiness and friendliness. What also mattered was participants' angry mood and hunger level, and to a lesser extent, being among strangers, which I didn't talk about because it didn't replicate perfectly across our confirmatory data set. Seems that different contexts don't matter for ratings of attractiveness or intelligence. And overall, we speculate that some of these effects might come about because participants' energetic mood and angry mood and hunger level are not exactly contextual effects, but they characterize features of the stable characteristics of the perceiver more so than the context. So in conclusion, we wanted to know, to what extent do different contexts matter in social perception? We found that context does matter, but primarily in an idiosyncratic manner across different perceivers. So between 15 to 18% of the variance was explained by this perceiver by context variance, and context on its own didn't explain any variance in any of these ratings. We also found that contexts do not seem to systematically drive face impressions in the same way across different people. And this suggests that at least for the purposes of this face perception research, most studies of face perception are probably not missing some crucial contextual component that might systematically bias results across contexts. As long as researchers recruit sufficiently diverse participants and use sufficiently diverse stimuli and account for the multi-level structure of these ratings, the results should be able to generalize to other contexts. And that concludes my talk. Thank you all for listening. I'd like to thank my collaborators, Hehman and Sabrina Thai, as well as my committee members. And thank you. Happy to take questions at any time. Space baby.
If nobody else has a question, I've got a few. So this is like a really different use of the word context than a lot of the context-specific person perception work, where they try to change the context in which you're judging the face, as in like, this is a person who might be a romantic partner, or this is a person you might be voting for. Whereas for you right now in this study, context is only like the things that are happening around the person, but they're still judging the face in the same context of, this is a totally random person you're never going to meet, and you get to judge their face on something random several times a day. Right?
Right. That's a great point. Yeah. And one of the limitations of our study is that, like, how do we define context? It could be the case that you're varying across situations, that you're varying the relationship of the person, or whether they matter to you, whether they can matter to you. In that way, context defined in that way would probably like matter for social perception.
Yeah, I mean, there's enormous amounts of work saying that that sort of context matters. I feel like what you're actually manipulating is sort of the participant's personal situation or mood, or not manipulate, but measuring.
Measuring, yeah.
In the sort of, I'm not quite sure what the right word is, but just be careful with the word context, because it pretty strongly is about the person judging and the person being judged. How do they relate to each other? And you're not that's not changing how they're relating to each other. It's just like the stuff that's going on with the participant. Are they in a noisy place, or like it sort of fits in with the general research, like on menstrual cycle effects, it's just like stuff that's going to change for the participant. Does that affect how they perceive other faces? But this is all really, really cool.
Thank you.
I'm surprised that there wasn't any, I thought at the very least, like if you're in a work situation and really busy, aren't you going to just like randomly button press more likely than if you're in a more relaxed situation? But do you think that this might just not be discoverable from your data, because if people are like regressing to the mean, for some people they're going to get lower, and for some people their average scores are going to get higher, and so that's all balancing out?
So I feel like there's different components of what you just asked here. So one thing that I picked up on was, and you can let me know if I like misinterpreted your question. One thing that I picked up on was, so it's true that participants, when they're responding to these surveys, they have to be in a place or in a situation where they can respond. If they're like being chased down by somebody in an alley, they're not going to be responding. And it's the case that we don't see a lot of variance on like frightened, people feeling scared or frightened. We also don't see any variance on people feeling extremely angry, which you would expect.
Hopefully those are like low occurrence.
Yeah, those are probably low occurrence as well. We do, surprisingly to me, see some responses from people who are in the romantic situation. So I think people are they're on their phones all the time. I think it's like, that's just a thing now. We probably aren't going to be able to capture those more extreme contexts. Those more extreme situations where we would expect the situation to have a pretty strong effect on participants' ratings.
Yeah, and like it might be that some things are having an effect in terms of like their attention to the task, but you can't tell because it's or that's being reflected in the participant by context interaction. Because for some people, getting closer to the mean drives their scores up, and for other people, it drives their scores down.
Could you say that last part, actually? That was really interesting.
So like if I tend to be a high rater, I give everybody 6s and 7s all the time.
Right.
But if I'm in a certain context, I'm just like randomly button pressing to get this task over with. So when I'm in that context, my scores go down. But you're a low scorer. You tend to give people 1s and 2s. And when you're in that context, you're also not paying attention and button pressing, but your scores tend to go up.
Right.
And so that might be causing some of this participant by context interaction, where people are doing the same thing. They're getting closer to the mean, but it's it's not directionally the same.
Oh, that's
Because
really fascinating. Yeah, I hadn't thought of that
but
potential.
it'll be hard to
confound
tell.
before.
And lots of other people have questions now, so I'll stop pestering you.
Okay, we'll return to your questions later if you have more. So I think Kathleen raised your hand first, but go ahead.
Sure. Well, thank you for the presentation, first of all. So in the PSA and other studies that have a lot of multi-lab kinds of data collection, we always take a lot of time and energy with documenting idiosyncrasies around the context, right? So what the lab room looks like, how many seats there are, how many. So I guess one reaction I had to this is, you know, I've always felt that quote unquote important effects, the contextual sorts of influences are going to wash out across labs. And I was wondering if you think that this research that you've done kind of shows that in some ways, that at least for person perception, maybe we shouldn't care so much about the setting of the study because the patterns seem to be in a way that they're not going to actually influence the results of an experimental manipulation, for instance.
Mm-hmm. Yeah, totally. I think that was like my personal takeaway from this research, where, you know, like my whole reason for doing it is, okay, we're always evaluating people on a computer screen. If you're in a different situation, or sorry, might there be ways in which the contextual factors like systematically influence your results? And what we find is that, no, not really. Yeah, we would expect these effects to wash out if we sampled appropriately, at least, and accounted for like the multi-level structure of different participants that we're sampling and the different targets that they're evaluating. But yeah, thank you for the question. And I think Katerina.
Yeah, Katerina is right. Thank you so much for your great talk. It was really an amazing study and an amazing story. And I wanted to return back to the Lisa's question about this: if you are fast, if you have no time, because I think it's really an interesting issue to discuss. Mm-hmm. In our study, we also conducted a sampling study, but I find your approach very interesting, that you combined questions with a task. We didn't do it, but I'm a bit familiar with this design. What we did, of course, during the data cleaning, we removed everyone who needed less time to respond. I don't know if it would be I don't know how much milliseconds, because at our place, every participant needed 3 minutes to respond for this questionnaire 5 times a day. And for those who needed less than a minute or 1.5 minutes, we removed this, of course, this answers, because it's for sure they were just fast. And so my question was, we also had other data cleaning procedures. There are so many what you can do. And my question was, have you done it? Maybe also delete or exclude those answers with higher ratings where there is no variance at all, always 666, 111. And my second question would be, because exactly the strength of this approach is to study the face perception outside the laboratory, like it's more close to our environment where we're living. But when we encounter faces, they're usually moving. So were you thinking about adding some movements without maybe emotions, but somehow that maybe next step that to make faces more dimensional, because maybe this could also affect, but I'm not sure, just a guess.
Okay, yeah, thank you. These are fantastic questions. So the first one about data cleaning, we totally did that. And I realize now that this actually sort of addresses the point that Lisa made earlier. It's just I analyzed this data like before the pandemic and forgot. But we have a pre-registered data cleaning procedure where we like cut participants if they are below, if they make ratings within like below 400 milliseconds, so each rating. And we also cut them if they like tend to make repeated ratings, just their ratings are like repeated. And I think the criteria we use is if they're across all the responses, if 30% are like repeats of the previous response, we would just cut that participant entirely. And that's probably why we like originally recruited 400 people and our analyses were performed on 218 participants. So I think this might be able to address the issue of like, are participants just haphazardly responding when they're doing the survey? But I mean, people can carelessly respond in like sophisticated ways. They can be like looking at something else and just like pressing buttons on a phone. So it doesn't eliminate that possibility completely, but it does make me a little more confident in the results. To your second question about whether we looked at like, yeah, so these are all static photos on a screen. There is another study that I did as part of my dissertation where we looked at whether like looking at a photo versus like a video of a participant who's like talking and expressing themselves, whether that would change. We didn't analyze it in quite the same way. So we didn't look at whether that would drive variance on these trait impressions, but we did look at whether that changes the structure of these trait ratings. So for example, we had two conditions where participants either looked at a photo or they looked at a video of the same person. And in the photo condition, we measured how the way that their evaluations of attractiveness and friendliness and competence and so on relate to each other. In the video condition, we did the same, and we just compared to see whether the structure of these trait relationships differs across conditions. And we found no difference across photo and video condition. But I would go back to that data and like analyze it in this way to see if whether there's more variance in the way that participants are evaluating individual traits. So thank you for that suggestion. Okay, any other questions or comments? Okay, I see, okay, yeah. So Savannah was giving me like these pro tips in the chat, like, oh, like Lisa DeBreen is very active and known in face perception research, and she led the PSA study.
I was just trying to give you like extra knowledge. I don't know.
No, much appreciated.
Looked it up and she's just like on the study with us. It's fine. My bad.
All right, Sally and I know each other.
If you have more questions, go ahead.
Can I ask a question about just, you probably went over this and perhaps I missed it. For how many ratings of each face do you have per participant in total?
Good question. So another thing we did was we cut participants if they made like very few ratings overall. So like if they just did the survey for a couple of days and they dropped out, we cut them.
Okay, so they did it how many times a day for 15 days?
So ideally they would do it 2 times a day for 15 days. If they missed 5 surveys,
or how many faces do they see in each session?
Oh, sorry. So in total, like they would have, so if they completed every survey, we would have 30 observations from each participant. And because we only have 15 total stimuli, which is much fewer than what's usually used in face perception research, every stimulus is evaluated twice by each participant.
15 total stimuli?
Yeah, 15.
Ooh.
So typically for those in the audience, in face perception work, you would use like at least 100 or like possibly even more. So you're capturing random variability across stimuli. The reason we only limited to 15 were, okay, so first of all, there's a practical reason. They're doing like a 2-minute survey. We don't want to bombard them with like a billion faces. But also we weren't really changing the stimulus's context. Like these were just faces presented on a white background. We're not changing the context of the stimuli. And we thought that by like holding them and controlling them in this way, we could isolate any like contextual effects to be more related to the perceiver's context rather than the stimulus context.
Have you done any modeling to look at sort of what might be going on with power in that situation? Like these are really complex models that you're running.
Yeah.
So wondering if you've got a lot of error in there because of the low number of faces, but I'm not sure how you can fix that within the constraints of your design.
Yeah, totally. We did do a a post hoc sensitivity analysis. Not great, but we did this just so we can see if we could actually get any effects. So this was, what was this? This post hoc sensitivity analysis was mostly to look at whether we had the power to detect these like within perceiver contextual effects for this analysis. And I can actually pull that up. Do I have a slide for this? Oh God, ICCs, okay, limitations, solutions. Wait, okay, sorry, I'm just gonna share my screen in a different way.
What was the cows for?
Yeah, cute animals and background.
My desktop. Where's my power analysis? Sorry, just give me 1 second. I actually really want to show you this figure.
If you've run a sensitivity analysis on a model that complex, you should definitely show people.
Yeah.
Show off all that work.
Where are you? Analysis. Okay, nice.
While you're looking it up, which data set were the faces from? Because I recognized faces in your talk from at least 3 data sets, I think.
Oh, you mean like the stimuli?
Yeah.
Oh, so for this study, the stimuli were Chicago face database. Yeah. So over here, we have the power curve for all these different variables. And our target effect was 0.2, just because like, we don't really care if they're, if it's like an effect of like 0.01, that doesn't matter. And for reference, usually the effect of gender on like ratings of trustworthiness we found in our research is like 0.4. So we thought a target effect of 0.2 would be good. And for our mood and psychological, okay, maybe I'll just, are you able to see this? Okay, for our mood and physiological variables, we found that at power, we were above 80% power at like 0.15. Same with situation, same with some of our environmental variables. The only exceptions were these 3 categorical variables, like, are you with a stranger or alone? Are you with someone you know or alone? And right, so these are dummy coded categorical variables down here.
Okay.
Yeah.
Cool.
I might have missed this, but kind of to jump off of Lisa's question about stimuli, how much thought did you put into like the range of like a priori ratings on some of the faces you chose from the database?
Yeah, great question. So my initial approach was like, let's just randomly sample from the pool and see what we get. But since we only have 15 stimuli, that probably wasn't a good idea. So what I also did was I looked at like their norming data from CFD, just to ensure that we had some variability on these faces, on traits like attractive or intelligence or whatever. Otherwise, everyone would just be, like we would just get the same rating for things. Yeah. So it was like a combination. It was a principled random sampling of stimulus data. But that's...
I guess I'm just curious if you thought about whether or not you like specifically would choose stimuli that potentially have higher, you know, variability on the norming data or something to try to get more variability across contexts and participants, or if potentially that stimuli selection as well as the number of stimuli in and of itself could have impacted your results and minimize the variability you were getting both in context or between participants.
Right, that's a good point. So like maybe our effects are underestimates because of our limited stimulus pool. And that is a possibility. And yeah, there was no, we like went back and forth about how many stimuli we should use. In the beginning, the idea was like no stimuli, we just have people evaluate other people in the wild. But then there's like so many problems associated with that. So we're like, okay, no, we have to use stimuli.
Yeah, part of me was like, oh, wouldn't it be so cool if they like took a picture of somebody they saw and did an evaluation so that.
Oh my God. Yeah, I mean,
I think
aside,
there
that would be really
IRB
cool.
problems with that.
Yeah. If I were to do this study again, I think, like, I don't know why I didn't do this before, because I use this tech in my other work now. I would have like sampled, I would have had like a pool of stimuli, like randomly assign participants to 15 from that pool, and then we have some target variation as well. But they only have to evaluate like one stimulus per session. Yeah, why didn't I do that? Okay, well.
The mixed effect models they open that up, but yeah, you might need then the study to run over more days to collect sort of, or have more participants if you're randomizing which faces people see.
Yeah.
But with Kathleen's question, I'm wondering if you could have a look at, so your general models, are they run over each attribute separately?
Yes.
Right. So I'm wondering if you could look to see if there's any systematic relationship between the variation that you have. Let's say your faces are all pretty close to the mean on trustworthiness, but they vary a lot in attractiveness. Like if you put me and Christy Brinkley into an image set, you're not going to get much variation by situation in people's opinions, because like Christy Brinkley is always going to be a 7.
Right.
Right? Like no matter what happens.
Right.
Whereas if everybody's kind of like right near the middle, then they might shift around in perception. So I'm wondering if there's any systematic relationship between, and you might be able to look at that with maybe your image, your set of 15 faces might be pretty homogeneous for one trait, but pretty diverse for another trait.
I'm gonna write this down. Sorry, just so this is a really cool suggestion. I think you mentioned like looking at whether like the mean of like the trait, and I guess like mean variability of trait predicts
and sort of like the variability of the trait among your stimuli, does that have any relationship to whether or not, or how much of these contextual factors you might see, or the interactions between context and participant?
Oh, okay.
But
it could also be in a similar line. It could also be looking to see, as you were saying, that there might be some people who are going high when they're inattentive or low when they're inattentive or something like that. It could be interesting to look at like the magnitude of differences from the norms on traits that you have normed data from the database, right? So you can see if there's more variability compared to the actual norm that you're coming in with of your participants based on certain contexts to show, to try to think about if it is kind of like it's impacting different people in different ways, maybe the degree of impact is different for certain traits in certain contextual conditions versus others.
Yeah, that's a great idea as well. Yeah, I'm getting so many good questions and comments and feedback.
I have a question because you used this cluster analysis before, latent, or how does it call again?
Latent profile analysis.
Yeah, can you use it on your stimuli to see whether these 15 pictures would maybe build different contexts? So that maybe 3 of the pictures belong to context, how attractive it is, and the other, if there is a variable which would split this sample into different characteristics. I'm not sure if it's possible, but so that you take this stimuli, you run this analysis and you see whether they can build a cluster. Some of the stimuli can build a cluster and the others will be in another cluster.
I think that's an interesting idea. I'm not sure if LPA can handle it.
Yeah, I heard about it, but I never tried that. You do it exactly with your variables, whether they build a cluster on their own. Like it was said before that maybe they share some certain, I don't know.
That's really interesting. So the way that like I did the LPA was I like the only inputs into this analysis were the contextual variables. So we're just looking at like whether a cluster exists among our predictors. And I left the DVs out of the model. I left the participant IDs out of the model. I left the target IDs out of the model. But I think what you're suggesting is like to include the target IDs into the model. And I'll have to think more about this. I mean, it's a really interesting idea. I would just have trouble interpreting what like the final cluster means, given that like targets are also in the model along with the contextual variables. It's like our target's a context in and of themselves that might be contributing to the context. Yeah, it's an interesting idea. Thank you. Okay, thank you all for your wonderful questions. I actually have to run because I have another meeting at 2. But I'm gonna leave my email in the chat. If you guys have more questions, suggestions, etc., please feel free to send me an email. Okay, thank you all so much. Bye-bye.